Hi, welcome to an Arduino tutorial from RoboJax. In this video, I'm going to show you how you can control the 28BYG48 stepper motor, the tiny stepper motor, to control it precisely with potentiometer. You will be able to control the seconds that will take for one revolution. You can set it for 20 seconds or maybe 1 hour, whatever you wish. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I have another video with a basic introduction to this 28BYG48 stepper motor with this module, which has been viewed over 100,000 times. I've read a lot of comments when people post it, and one of the requests that I've seen was to control this motor with a potentiometer. And also there was another request that how to control this motor with 2 push buttons or 3 push buttons, so it can by pressing one push button it rotates to clockwise, and pressing the other one would be counterclockwise, and then another button for stopping it. Also a stop button to stop the motor to the clockwise or counterclockwise, whichever direction you want. We're going to control the speed of this motor using Arduino and the potentiometer. This is the code where you can control the speed of this. With my calculation and experiment that I did with 5 volts that you supply, because this is 5 volts motor, and with the 5 volts that you supply to this, either through Arduino or directly, one revolution of this will take 5 seconds. That is what I did, and let me show you now. This is from this point. You will see that it will take 5 seconds to complete one revolution. Again, pay attention. When it reaches here, it will be 5 seconds. That is the maximum speed, and you can slow it down, but I made this very easy to be used, so you can enter your time for revolution. For example, you can set the revolution of this to take 10 seconds, so you can make it 10 seconds or 15 seconds, 20 seconds, 30, 40, 1 minute, 2 minutes, even 24 hours if you wish. You can enter the value in second, and the code that I will going to show you. Let me explain the wiring. If you need the wiring diagram for this, it will be available as part of my Arduino course on Udemy, which you can purchase and get all the schematics for circuits, libraries, all together in one. The link will be provided, but here let me explain the wiring. For the motor, we will connect the motor directly to the board, so you do not make any mistake here. When you receive it, it might not be plugged in, so just plug it in. You don't worry about the wiring. For this side, we have these pins, N1, N2, N3 up to N7, because we are using it for 4 pole, only up to 4 have been used. So N1 to N4, I've inserted 4 wires here, and these 4 wires are accordingly connected here to pin 10, 11, 12, and 13. And here, this side is ground. It has been connected using this brown wire to the ground, and this side is VCC or 5 volts. I've connected it to 5 volts of Arduino. If you want to supply power from outside, remove this jumper here, put this in the last one, and then connect your external battery or power in here. This is my power supply, external power supply. This is ground, this is positive. You must connect a ground to the ground of Arduino because it should be common. And this wire, which is for 5 volts, will be connected to your power supply. Then it will operate with using external power supply and not from your Arduino. And for your potentiometer, you will get any variable resistor, anything above 1 kilo ohm or above, that is fine. I've used here 100 kilo ohm, does not matter. I'm rotating it to the left and then putting this line on this side. So now I know this is minimum, and when I rotate it, this is maximum. Connect the left side to the ground. I'm using the ground here on Arduino, this ground. And the middle one, this is very important. The middle one must be connected to analog pins. In this case I'm using analog 1, you can use analog 2, 3, 4 or 5, or if you have Arduino Mega connected to any. This pin that is to the right, this will be connected to 5 volts. In this code we have defined pin 2 as additional 5 volts for this, so I'm connecting it to pin 2. If you have another 5 volts, that's also fine, but here I'm using it for this purpose at pin 2. Quickly just remind you that I've spent a lot of time preparing this code for you so you can easily use it. The least that you can do for me is to click on the subscribe button and leave the notification on. Thank you. Now let me explain the code. We start, this is what we call desired value. This number is a value that you want the rotation to be completed in this many seconds. So this is 20 seconds of one revolution. If you put this, that's the minimum that you can set, and the maximum speed will be when you rotate potentiometer, it will be 5 seconds one revolution. So keep that in mind. This motor can rotate 5 seconds in one revolution. So we can set here 1000, 2000, whatever you want, that amount of seconds in one revolution. And from here you can select the direction. If you want it in the other direction, just change it to 1, and depending on your application, either 1 or 2. And these pins, as you can see, pin 1, pin 2, pin 3, pin 4, we are defining it, pin 10, 11, 12, that's for N1, N2, N3, and N4. We mentioned we are using these pins. If you wish, you can change them. Analog 0 is the pin that middle pin of potentiometer is connected, and I call it pot pin as an integer. And then VCC2, this is pin 2, will be defined for second 5 volts or second VCC, because potentiometer needs also 5 volts, so we are defining that. Remember, we will connect potentiometer to this pin, not motor, because the pin cannot handle the current for the motor. And these are the pole values for this motor, for this particular stepper motor. And because we have 4 poles, for each pole I've selected this array, and these are the value for the array, which has 8 steps, 4 and 4, and this 0, 0. Whenever you need to turn it off, you can use this. And this code have been used in my other video. The link will be provided for that video, which you can control the motor with a push button. And pole step, do not change this. This is used internally, and this is called function prototyping. This is a function which I have defined below the code, which I will explain next. And this driver step is another function. This is also prototype for that, which I will explain next. And this line, we will get the desired value and pass it to calculate delay from time to this, and this will return a proper value that we need for this code, and we call it n, which will be used later. Inside the setup, we define all these 4 pins as output for the motor board, and this is VCC pin as an output. And immediately in this line, using digital write, we set this digital pin as high, so we have 5 volts for the potentiometer. This is just printing information, 9600 baud. This is initializing the serial monitor, which you can click at the serial monitor here, and if you need it, it will show you the value and the delay that you can. On the lower right corner here, on the right side, with mass match. And then we wait 4 seconds for the user to read this value, and then the motor will start working. Inside the loop, this is the code which will run continuously. The code that is inside the setup will run only once. So here we check if the direction that we set above is equal 1. Remember, we set the direction in here 1 or 2. Here we check if the direction is 1, we set pole step plus plus, so we are incrementing it. The loop goes every time it comes, it adds up, and then we pass this value here to this function which is called drive stepper, which I will explain next. Else, if the direction is equal to, then we do decrement. This is increment plus plus. Decrement mean whatever is this value, subtract 1 from it. and then we pass this value, and this causes the motor to rotate in the other direction. Else we pass 8, number 8, and 8 is to get the motor stop, which will not be used in this code. And these are the code that is not allowing anything to go above 7. If anything is above 7, it sets it to 0. If anything is below 7, below 0, it sets it to 7. So these two if conditions will not allow the pole step to go above 8 or below 0. In this line, we use analog read pot pen, which we have defined at the first, the top of the code. We are reading the potentiometer value and stores it here. We call it pot value as an integer. And then using the map, we will convert it to the delay value that I've calculated to control the motor. We get the pot value, which is from 0 to 1023. This is the minimum, this is the maximum, and we map it or convert it using this function between 1 to the n value. N value is the one that you have entered above and it has been calculated. This value that you enter here, from this we convert and do calculation and make it n, which has a formula. I will explain it next. And here is how we can calculate the time of one revolution of the motor, or the time of the revolution, if you put the delay in the delay function in Arduino inside the loop. And if you put inside the loop 1, this is the time that will cause the motor to rotate one revolution. So 1 times 4 is 4, 4 plus 1 is 5. It will take 5 seconds to do one revolution. If you put here 2 inside the loop, then will be 2 times 4, 8, 8 plus 1, 9. It will take 9 seconds to complete one revolution, and so forth. And here, if you put delay 1, it will be 5 seconds based on the formula that I've shown you. If you put 2, it will be 9 seconds. 3 will be 13 seconds, and so forth. And here is a plot of the same thing. If you plot it, you will see it's a straight linear equation that works, and you can continue for other value, but simple. This is just very simple formula linear equation. Speed. From this we get a speed, a number. Now the delay that we have is, this is comment. I've used it when I was debugging this, so do not uncomment this. If you uncomment this, the motor will slow down and never run with the fastest speed. So I've just left this here. And that speed that you get will be a number, something 1 or higher. The higher this number, the slower the motor. So we can control the motor with that, which is directly connected to potentiometer. That's why you can control the speed of motor. And then calculate from time. This is a formula to calculate it. And that is the t that you pass, the number, for example, 20. So t minus 5 divided by 4, and everything plus 1 will give you the delay time for the speed, which is used here for this n. And this is the drive stepper function, which I mentioned here, this one. The drive stepper function will get the value that you pass. For example, you pass 1, 2, or 3, whatever step that you have. You go to this C means go to this pole 1 array, pull the C value. If it is 1, it goes to the number 1 and pull it up. Let me show you the pole 1. For example, it comes here, and this is 0, this is 1. If it is 1, we pull the value from here, which is 0. For pole 2, we go here. For pole 3, we go here. All of this line, these are all 0, these are all 1, these are all 2, 3, 4, up to 8, up to 7 here, and the 8 is 0, 0. So we get the pole, the value either 0, 1, and we pass it to pin 1 using digital write, and then also from pole 2, pole 3. So this, all of these 4 will run together, controlling the motor. Do not change this. Not change this. The only thing that you need or you can change are these values. This, and these pins if you're using it for other purpose. And here is a demonstration. I have not connected external power. This is just directly, and the blink of these will tell you how fast it is. But if the speed slows down, you will see certain blinks at very low speed. But after certain speed, you will not be able to distinguish if it is fast or slow. But here, this is now at the maximum speed that this motor can run. So keep that in mind, that you cannot speed it up more than this. And this takes, from this point, it takes 5 seconds to complete one revolution. And I've set this now for 25 seconds, so I can slow it 5 times slower. So if I go all the way low, from this point, for example, you can see that it will take 25 seconds to complete one revolution. We just wait for this to complete. And here you go. Let's make it 40, and I'm uploading the code. So the code has been uploaded. If I go all the way to the right, if I go all the way to the right, that is 5 seconds per revolution. But if I go back to the left, this will now complete one revolution in 40 seconds. Here, let's see now, one complete revolution in 40 seconds. And as you can see, it took 40 seconds. But if you want to speed it up, we can change it to 90 seconds. Which means now it's at the fastest point because I've put this to the maximum. But this will take 1.5 minutes, 90 seconds to complete one revolution, this value that you see here. So let me slow it down, and as you can see the blinks, and this is moving very slowly. Let's make it 300 seconds, 5 minutes. So now with this value, it will take 5 minutes for the motor to complete one rotation. And you can see all the blinks. This is now moving, but it is very slow. So when I put this potentiometer, this is on the left side, that is the slowest, which is this amount, 5 minutes or 300 seconds. But if I rotate it to the right, it will speed up. And if I go far to the right, that is the normal 5 seconds one revolution, which is the standard speed of the motor. Again, if I go here, we can do it also fast, slower, like 900. Now it's 15 minutes. Now this will be 15 minutes. It will be very slow, but you can see all the blinks. Of course, I will not wait for the 15 minutes, but this is how it would happen. And it can be used for many applications. And if I hold it in my hand, you will see every time this light blinks, you will hear a mechanical bump. Whether if you're studying mechatronic, electrical engineering, hobbyist, researcher, or high school student, I have an Arduino course that will teach you from ground up Arduino. My Arduino course at Udemy is arranged such that all the material are structured from absolute beginner to advanced, including all the library, codes, schematic diagram, and explanation step by step for all the projects are available to you. In no time, the knowledge that you gain from my course in Arduino, you will be able to implement it and build cool robotic or mechatronic projects that is beneficent for you and people around you. The link for my course on Udemy is below the video in the description. You can visit it now. I would like to sincerely thank the following people who have supported me via Patreon. Thank you for watching. This was how to control the 28 BYG48 tiny stepper motor with potentiometer. I will have a lot of other videos related to this motor. Make sure to subscribe so you can get updates of my upcoming videos. If you have comment or question, post it at the comment section below. I try to answer and reply.